Hi, welcome to section 9.1, the law of sines. Today we're going to look at solving what we call oblique triangles. So you need to make sure, number one thing, is that these triangles today are not right triangles. Okay, so these next two sections, when you do the law of sines now with me and when we do the law of cosines, you only can use these formulas when the triangle is not right. Okay, has no right angle. If it has a right angle, then those are the ones where you use your trig function, sine, cosine, and tangent. Okay, using your ratios. You know, sine is opposite over hypotenuse, and cosine adjacent over hypotenuse, and tangent opposite over adjacent. You only use those in right triangles, which is what we've been spending most of our time on. So these last two sections are about triangles that don't have a right angle. So these are called oblique triangles, and you can have oblique triangles that are acute, where all the angles are less than 90, or you could have an obtuse triangle that's oblique, that has one obtuse angle bigger than 90, and then the other two would be acute. Okay? So it's real important, because I'll have students sometimes that try to use the law of sines on a triangle that's right and you get the wrong answer, or you try to use your trig functions on a triangle that's not right and you get the wrong answer. So you have to make sure, be very careful, that you're using the right formulas. All right, so before we get into the law of sines, this picture on your notes just kind of tells you what kind of triangles, how you know you're going to use the law of sines versus how you know you're going to use the law of cosines, which this will be in the next section, 9.2. But I wanted to put them all here because you remember back in your basic geometry courses, you learned about congruent triangles and you labeled them based on their sides and angles that were given to you and which ones were congruent. So if you remember, you had angle, side, angle, angle, side, angle. You had side, side, angle, side, and then there's a sixth one that's angle, angle, angle. Well, in this section and in these next two sections, you're going to be given 3 of the 6 pieces of a triangle. Okay, so every triangle has 6 pieces, right? 3 angles, 3 sides. You're going to be given 3 of those 6. So if the 3 that you're given fall into this category, that's how you know you're going to use the law of sines. And if you're given these, then you'll use the law of cosines. You would never be given angle, angle, angle. You would never be given the 3 angles, because there is no way to find any sides if you're not at least given one side. So none of these would ever be angle, angle, angle. So it's not even one of your choices, because you can't do that. All right, so just remember that the way these letters are written are how these things come to you. So if you'll notice, this says angle, side, angle, which means you have 2 angles and 1 side. But if you look here, side, angle, angle, that's still 1 side and 2 angles. So why are these different? Remember that the letters are written the way that the pieces are given to you. So angle, side, angle simply means that you're given an angle, the side between the angle, and then the next angle. Okay, so C is between A and B, so the side is between the 2 angles. Here, you're given 2 angles and then a side that's not between them. So if you list them in order, the side is first, then the angle, then the angle. So that makes a difference, because it's different on how we're going to solve these things. Okay, and then on this one, side, side angle, you're given 2 sides and then the angle. Notice the angle is not between the 2 sides, so that's why it's written this way. Now the other one of these, the 2 sides and an angle, is right here. Notice you're given the 2 sides, but you're given the angle that connects those 2 sides, so that would be the angle in the middle. And then obviously side, 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 you're just given 3 sides. Okay, so hopefully you remember that from your basic geometry classes, but if not, that's how you're labeling them. So again, there's 6 possibilities. The last one is angle, 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 but we can't do those. You can't solve anything that's given to you that way. Okay? All right, so today we're going to look at the law of sines. Basically, we have what I call the easy ones, which are angle, side angle, and side angle, angle. And then we have a little bit harder one in side, side angle. Okay. Back in geometry, a lot of teachers in high school never teach this. They actually would tell you to write it the other way, ASS, where it's a bad word. So some of you may remember that, your teachers would say if you have the ASS, you can't do those. Well, you can do them. It's just they usually aren't taught in basic geometry, but you can. They're just harder. So now that you're in college, we're going to do them. They're harder. So we're going to touch on these, okay? All right, so we're going to start with these two because they're the easier ones. Your formulas are very easy for the law of sines. So let's look at that, and then we'll get started on solving some. All right, so it says the law of sines. If you have a triangle ABC, okay, and they have sides of length ABC, and remember the sides always are the lowercase, and then you have the opposite angles, A, B, and C, which are your capital letters, always represent angles. Then the law of sines is the sine of A over A equals the sine of B over B equals the sine of C over C. Now, if you've learned this before, some of your teachers or some books teach it this way. It's the same exact thing. It just, whatever you put in the numerator for one fraction, you got to do it the same. So if you put the side on the top and the sine of the angle in the bottom, then you just got to keep your ratios that way. Now, you're not going to set up 3 different fractions. This is a ratio, so you're basically going to pick 2 of these 3 things to set equal to one another, and that's based on what's given to you in the problem. So if you're given A's and B's, then you're going to use this. If you're given B's and C's, then you would set these 2 equal. If you're given A's and C's, then you would set this equal to this. Okay? Now I use this form because that's what I'm used to using, but like I said, if you do it the other way, it's fine. Okay? So it's real simple. You're just going to set up a ratio and solve it, and that's that. Now, remember with these, since we're using triangles and we're in degrees, we're going to make sure your calculator is in degree mode so that you get the right answer. Okay? So let's look at some. Now, the other thing I want to mention to you before we move on is 9 times out of 10, it doesn't matter how you do these problems, but every now and then there's going to be a problem where you may or may not get the right answer if you don't find the right angle or side first. So I always tell my students, just to be on the safe side, that when you're using the law of sines, okay, and since that starts with the letter S, you always want to start by finding the smallest angle first, or the smallest piece first, I guess I should say, because it might be an angle, it might be a side. Okay? So when you use the law of sines, you want to always start with the smaller pieces. And then when we do the law of cosines, we're going to start with the larger pieces. Now, like I said, most of the time it won't affect your answers at all. But every now and then it will. So if you do this and get yourself in the habit, then you'll never mess up. Okay, so it's just a good rule of thumb to kind of go by. All right, so let's look at the first problem. It says solve the triangle and then round your lengths to the nearest hundredth. So remember, when you're solving, when you see this, solve a triangle, that means find all of the missing pieces. All right, so if we look at the triangle given to us, they gave us angle B, they gave us angle A, and they gave you side B. Remember, when you draw your triangles, the opposite side always has that same matching letter, right? So we need to find angle C, we need to find side A, and we need to find side C. That's what solving the triangle means, find the missing pieces. Sometimes you'll just get a question that says, find side A. It might just ask you to do one of the things. But when you see solve the triangle, that means find all the missing pieces. All right, so looking at this problem, the easiest thing to find right now, and by the way, what is this in terms of those 5 different types of things that we were given? We have a side, we have an angle, and we have an angle. Okay? The side, we have an angle and an angle. And the side is not between these two. So this would be side, angle, angle. Okay? That's how we would write that. And you could write it angle, angle, side. It's the same as that. Okay? Either of those is fine, but this is the way the notes say it, so I wrote it that way. All right, so we need to find, and I'm just going to write a little box up here, we need to find capital C, right? That's the angle. we need to find side A and side C. All right, so these are the things we're looking for. So these are going to be our answers up here. Okay. All right, so easiest thing to find right off the bat would be angle C, because I know that all three angles of a triangle have to add up to be 180 degrees. So if I add these two up and subtract from 180, that would give me angle C. So that's an easy thing to find. So angle C would be 180 degrees minus 105 minus 48. Right? Put degrees there. Okay, so start with 180, subtract those two, that will give you angle C. So angle C ends up being 27 degrees. So now I know that. All right, so found one of my three missing pieces. Okay, so now here's where I'm talking about what am I going to find first. I want to start with the smaller thing. So is A smaller than C, or is C smaller than A? Well, based on my angles, since C is the smallest angle, side C is the smallest side. So I'm going to start by finding side C, which means I'm going to start with the sine of C over C. Okay, because that's what I'm going to be looking for. Now, the other fraction, I got to know both of the pieces. So I don't want to use A because I don't know A. I know angle A, but I don't know this. But look at your B's. I have angle B and I have side B. So that's the other piece of this ratio. So I'm going to use the sine of B over B. Okay? That's how you know what to do. The one you're going to look for, and then the other one has to have both pieces. All right, and this is a very simple process, so let's put in our numbers and work this out. So we're going to do the sine of angle C, which is 27 degrees, over side C, which I don't know, equals the sine of angle B, which was 105, over side B, which was 27. Okay? All right, so you're just plugging in what you have, and then to solve this, you're going to cross multiply. Okay, we're going to do 27 times the sine of 27, and then C times the sine of 105. And cross multiply any way you want. I'm going to put the C on the left, just so it's kind of the way we've been working out things. Okay. All right, now, you can do this and get your decimals now. I kind of just wait and do it all at the end just for time's sake. So, you can go ahead and put 27 times the sine of 27 in your calculator, get that answer, and then keep going. But like I said, I just do it all at the end. Now remember, make sure your calculator is in degree mode. So lastly, I'm going to divide both sides by the sine of 105. So C is going to be 27 sine of 27 over the sine of 105. Okay, and now I'm going to put all that in my calculator. So I won't show this up here every time, but let's just make sure. It's kind of dark anyway, so I'm going to do 27 sine of 27. I like to hit enter when I do that. And then I'm going to divide that by the sine of 105. Okay, so that gives me 12.690, said round to the nearest hundredth. So 12.69. Okay, so that's side C. Now that I know side C is 12.69, here's a very common mistake that some of you will make, is that you think since you have these two sides, you can do the Pythagorean theorem to find this. No, you cannot. Remember, the Pythagorean theorem is for right triangles. You got to have a hypotenuse. This triangle does not have a hypotenuse because it doesn't have a right angle. Okay, so the only way that I can find side A is to do another one of these law of sines. Okay, so if I'm looking for sine for A, that means I'm going to use the formula, the sine of A over A. That's what I need. And then this fraction has to be two sides that you know. Well, now that you know C, both of them, you could use it. Or you know both of B's, so you could use it. It doesn't matter. I'm just going to use B because those are whole numbers and no decimals. So I'm going to also use the sine of B over B. Like I said, you could do the sine of C over C now because you have those dimensions. Okay? All right, so the sine of A, so the sine of 48 over side A, we don't know yet. And then the sine of B, which is 105, divided by side B, which is 27. And again, you're just going to cross multiply just like we did and solve that. So this time we're going to get A times the sine of 105 equal to 27 times the sine of 48. Okay, so you're just cross multiplying. And then divide both sides by the sine of 105. Okay, so you're going to put that in your calculator. 27 times the sine of 48. I would hit enter, then divide by the sine of 105, and that ends up giving you 20.77. So there is side A. Okay. Now, I always tell you guys, you know, it's hard to check to know that you're exactly right, but what I always tell students to do is just look at your numbers and make sure they make sense. Remember when we said 27 was the smallest angle, so this should be the smallest side, and 12 is the smallest side out of these numbers, right? 48 was the middle angle, so this should be the side that's in the middle, which it is, and then this is the bigger angle, that should be the largest side. So even though you can't check, you know, for 100% accuracy, at least getting numbers that are in the right order kind of tells you you did it, you know, you were on the right track and you probably did it correctly. Okay? All right, so that's the basic one. Angle, side, or side, angle. When you're given the two angles and a side, that's basic step. All right, and so is number 2. So let's look at number 2. Solve the triangle with angle A 32, angle B 78, C is 57. All right, this time they didn't give you a picture, so you can just draw the picture. It doesn't really matter. I don't really know if this is an acute or an obtuse triangle, so your picture's not going to be probably exactly right, but that's okay. So just draw yourself a triangle, okay, and just label it however you want, A, B, C, okay. And then this would be little a, little b, little c. Now, you don't have to do it like that. You know, you can do it any way you want to, but if you're following along with me, then make it look that way so we can do this together. So they gave you angle A, which was 32. They gave us angle B, which was 78. And they gave you side C, which was 57. Okay? All right, so what do we have? Look at our picture. They gave us an angle, the side between the angle, and another angle. So this is an angle, side, angle problem. Still got two angles, but this time the side they gave me was in between those two. Whereas this one, they gave you two angles, but the side was not between them. It was, I'm looking at my numbers over. Gave you these two angles and then gave you a side that was not between them. Okay, so that's the difference in writing it. All right, so we're still going to do the law of sines. So let's kind of think about what we have. Okay, we have angle A, angle B, side C. So again, I'm just going to write what do we need to find. I always like to do this. So we still need to find angle C, and then we need to find little a and little b. Those are our three things that are missing that we have to find. So just like this one, the one before, I have two angles, right? So I could always find angle C by subtracting these two from 180. So to find C, we would do 180 minus 32 minus 78. Okay? Remember, your three angles have to add up to be 180. All right, so 180 minus 32 minus 78 gives us 70. So there's angle C. All right, so now we know that. Okay, so smaller thing first for the law of sines. So A and B, out of my two sides, I'm going to start with side A because side A is smaller than side B based on the angles. This is the smallest angle. That's got to be the smallest side. So I'm going to start by finding the sine of A over A. And then remember, your second fraction is got to be two things that you have the answers or you have the numbers for. So I can do C, I have both of those. I can't use B yet because I don't have side B. So this is going to be my other fraction. So the sine of C over C. So that's how you know it. So it's pretty basic for you to kind of figure that out of, which ones you're using. All right, so let's plug in what we know. We know angle A is 32. We're looking for side A. We know that angle C is 70, and we know side C is 57. So these are all very similar. Once you get going, we're going to cross multiply and then divide. So A times the sine of 70 equals 57 times the sine of 32. Divide both sides by the sine of 70. And then put that in your calculator. Okay? So 57 times the sine of 32. And then divide that by the sine of 70. And you should end up with 32.14. Okay, so there's side A. All right, so now we have side A is 32.14. And so the last thing we're going to do is find side B. So that is the sine of B over B. That's what we're looking for. And now again, you can use either your ratio for C or you can use your ratio for A. Doesn't really matter. I'm just going to stick with C because again, this is not a decimal, just easier for me to write out for you guys. So I'm going to do the sine of C over C again. All right, so this time angle B was 78, so the sine of 78 over B, what we're looking for. And then the sine of 70 degrees, that was angle C, over side C was 57. All right, let's cross multiply and do that. So we have B sine of 70 equals 57 sine of 78. Divide by the sine of 70. And get your answer from your calculator. Okay, so 57 times the sine of 78. Get that first, and then divide that by the sine of 70, and you should end up with B being 59.33. Okay, so 59.33. All right, so again, if that's correct, just check your sides. A was the smallest angle. That's the smallest side. Yes, it is. B was the largest angle, so this should be the biggest side, and it is. It's bigger than 57. So again, not a surefire way to know that I did this exactly right, but pretty accurate that since my sides are in the right order, I did it correctly. Okay? All right, so those are the basic ones. All right, now we're going to spend a little bit of time talking about the next page. It's real important that you understand how you're working these problems, and then we'll look at a couple of these ambiguous cases that we're getting ready to do. All right. So, what about side-side angle? Okay, so let's kind of go back before we look at this. So we've done these two. Okay, those are the easy ones. So think about this. When you're given two angles and a side, those are easy ones. When you're given two sides and an angle that's not in between the two sides, that's going to be the harder one. Now, if you're given two sides and the angle in between, then that is a law of cosines problem, and that's easy. So it's real important that you draw the triangles and know which of these two you are given. So today we're looking at these. Two sides and the angle not in between them. This would be the angle between them, which we're not given. Okay? Notice here, that's the angle between the two sides. All right, so we are looking at this, which is called an ambiguous case because there are several things that could happen. Okay? All right. It says, suppose that the measure of angle A and the lengths of side A and B of a triangle are given. depending on the length of side A, shown in pink or red, depending on your printer, relative to the length of the altitude h, we have 4 different scenarios. All right, so here's the thing. In here, please be aware that all of these letters are referring to the fact that they gave you side A, side B, and angle A. Not every problem you do is going to have those 2 or those 3 things given to you. You might be given B, C, and C, okay, or whatever. So you got to be really, you got to understand this process and not just look at these letters, because you can't memorize these letters because they're going to change based on the information given to you. So for me, and this is why I'm teaching it this way, is every time I'm given a side-side angle problem, I'm going to draw the angle that's given to me always in this bottom left corner and the side opposite it over here, because this is the side that's in question, okay? And then the other side that's given to me, I'm always going to put on the left of the triangle. So I'm always going to have the same picture no matter what these letters are. So we're going to look at the picture and not so much these letters, okay? All right, so always when you do these, except for this case, okay, you really don't need to do H in this case, okay? So even though it's in the picture, I'm going to write here, we don't need to find H. Okay, we don't need to find H on this scenario. So what is this scenario? Let's start with this one. So if you're given angle, the side opposite that angle, and another side, if this side is bigger than this side, you automatically have one triangle, and you can do it just like we did those first 2 problems. This is the easy one, because you will get one triangle and you find it exactly the same way that we've been doing it. Okay, so I'm also going to put easy here because there's nothing new with that one. Notice there's no H in this setup here. Even though they show it here, we don't need it. Okay, the reason why we don't need it, think about this picture right here. If I don't have this triangle, let's just look at this triangle on the left. This is the hypotenuse, right? B is the hypotenuse of the black triangle right here. So if A is bigger than B, automatically A is going to be bigger than H because H is smaller than B. It has to be. This is the side of the right triangle, but since this is the hypotenuse, B has to be bigger than H. So just by default, if A is bigger than B, it's automatically bigger than H. So there's no reason to find H because I know A is bigger than that. Okay? All right, so hopefully that makes sense. But for the other cases, we have a problem because A is not going to be bigger than B. And if it's not bigger than B, then it matters whether or not it's bigger than H or not. So now we got to start finding H. Okay? All right, so here's where, again, I'm just hopefully getting you guys to understand this and, not worry about the letters so much. So we will have to find H, okay, on any other case but this one. Okay, what was this one? This is when the side opposite angle A, or opposite the angle given to you, is the biggest side. That's the easy one. All right, now, we know that the sine of an angle is the opposite side over the hypotenuse. So if you look at our little picture, the sine of this angle is the opposite side over the hypotenuse. So that's where this is coming from. Now remember, our letters are going to be different sometimes. We might have, this is angle C and this might be side A. So what I need you to remember is to solve for H, you would multiply the B to this side, right? So that's why we have H equals B sine of A. So we just multiplied the denominator, B, over here and got B sine of A. So that's where that comes from. This is what I need you to kind of look at. So to find H, you're always going to take the side that's over here and multiply it by the sine of this angle. So I don't care what the letters are. You will always use this side and this angle. to find h. That's more important. But we have to give you the formula somehow, so we're just using these pictures. So I know I'm spending some time on this, but this is real important because if you don't understand that, we can't go any farther. All right, so a couple of things are going to happen. The easy problem is when a is smaller than h. Because if a is not even as long as h, then it won't touch over here. And if it doesn't touch over here, it can't make a triangle. Because remember, we're trying to see how many triangles we have given these two sides. So if a is not any bigger than h, then we're done. The pieces given to you do not make a triangle, so you can't solve it because there is no triangle to solve for. Okay, so that's what this is telling you. If this side is smaller than h, no triangle. Now, every now and then, very rarely, will you get this case, but you might. You might get that a is exactly equal to h. Well, if a and h are exactly the same, then that means it's going to fit right here. And that means you have a right triangle, so you could actually go back and solve it using your trig ratios. Okay? So if it's a right triangle, then a would equal h, and then you'd solve it using your trig ratios. Okay, what we learned in the last few chapters. All right, but again, in this section, 99% of the time, you're not going to be given this, okay? Because we've already done these 100 times, so we know you know how to solve this. Okay, so no triangle, one triangle. So how do we get two triangles? Well, that's going to happen when side A, the side in question, is between the lengths of this side B and the side H that you found. Because if it's between those two, then think about that length, okay? The length would fit here and make a triangle like this, or that same length could fit over here and then give us this triangle right here. So these are the ones that take a little longer to solve because you've got two triangles and you have to solve for all of those pieces. Okay? All right. So spend enough time on that. So let's kind of look at the strategies I'm going to give you to kind of help you do this. So steps to do this. Step 1 says use the law of sines to find the sine of one of the missing angles. If this value is greater than 1, stop, because there's no solution. Now, that's the one where the side is smaller than h. Okay, now, this part I'm changing up because I think that what I'm going to show you is a little bit easier. So we're not going to do that. We're going to do the h equals b sine of a here. But again, according to our sides. Okay, so I know I said find the sine, but we're going to actually find h. Okay, so let's change that. Find h. Okay. All right. Then it says, if the number obtained in step 1 is less than or equal to 1, let the values... Okay, so this is when we're doing two triangles, so let's kind of just skip that for a minute. We'll come to that when we do the problem where there's two triangles. Because what this is saying is that we know that these two angles, if you look at this as an isosceles triangle, these two angles are the same. So to find this angle, it would be 180 minus this angle. So that's what that little piece is saying. So we'll get to that in a minute. All right. And then we're going to just use the law of sines to find the remaining. Let me read number 3. Determine the third angle possible. Yeah, so we're going to go through this. So let me go through it instead. I don't know if this is going to be the best steps for you to follow. I think just, from teaching this a lot, I think if you understand this picture, this is going to kind of take care of all of the steps for you, okay? So the big thing is we got to figure out how many triangles we have first, and then we'll figure out what to do with that, okay? So yeah, I apologize for that strategy. That's a little bit different depends. I have taught it that way before, but honestly, I think the way I'm doing it is going to help you out a little bit more. It's a little bit easier. I say that, I hope so. We can go back and look at that other way, but I think you'll see that this is a little bit more straightforward, I think. All right, so let's look at example 3. Solve the triangle with angle A being 28 degrees, side A 12, side B 38. All right, so how do I know this is this case that I'm talking about? So always, if it's side-side angle, okay, always, if it's side-side angle, the two sides you'll be given, and then the angle you're given will be one of these two letters. So if this was C, then this would be a law of cosines problem. Okay, so to know that you're going to be doing these ambiguous cases, look at your two sides, and then if the angle is one of those letters, then that's what we're working on. So we're going to start with this angle being in the bottom. Okay? So remember, every one of these, if it's an ambiguous case, we want the angle in the bottom. So this one is actually going to work out kind of like the examples, but then the next one you'll see it won't be. So angle here, so the side opposite that, I'm going to put a question mark here. This is the side in question. Is this side big enough or not? And then the other side given to you will always go here. So I don't care the letters. This is how you set it up. Okay, the angle given to you, the side opposite that angle, and then the other side. All right, so we know that this is 28. Side B is 38. And side A is 12. Okay? All right. I would be done if this was the biggest side, because that would be the one triangle, the one that I said was easy, but it's not. Okay? 12 is not bigger than 38. So now I need to see, is it bigger or in between or smaller than the height as well? So we're going to drop down that height. Okay? All right. So remember, now we got to find h. And to always find h, you take this number times the sine of this. That's why I always set it up this way. So we're going to do 38 times the sine of 28 degrees. Okay, 38 times the sine of 28 degrees. Put that in your calculator and you will get 17.84. All right. So not only is side A less than side B, it is also smaller than side H. If it is smaller than both of these, then there is no triangle. So I'm going to say there is no triangle since 12 is less than 17.84. Okay? It's the smallest side. It's smaller than both of these. So that means I don't have to solve a triangle because there is no triangle to solve. Okay, so that's the first of those cases with the ambiguous case. All right, let's look at example 4, because now here's a good situation because we've got different letters. So notice I have two sides, and the angle given to me is one of these letters. It's a C. So that's one of these cases. It would not be one of these cases if they gave me angle A, because that would be side angle side, and that's different. But this is side angle based on what I just told you. All right, so when we draw this triangle, this time C is in the bottom. The side in question is side C. That's the one we're looking at. And the other side will always go here. So that's what I'm talking about, setting them up the same way, okay? Based on the information, the angle in the bottom left, the side that's opposite that, and then the other side, whatever it is, okay? So they gave me angle C was 68 degrees. All right. Now, look at your sides. Okay, this was the easy one, because if this side is bigger than this side, I don't have to find h. Okay, I'm going to draw it in here, but I don't have to find h since C is bigger than B, right? Remember that. If this is the bigger side, I don't have to find H because H is automatically smaller than B. Has to be because this is the longer side of this triangle. And all I needed to know, I got to figure out three things. Is it the biggest side? Is it between these two sides? Or is it smaller than the smallest side? Okay, so if it's bigger than this side, this is one triangle. So if there's one triangle, then we can solve it. So this was the easy one. One triangle because side C is bigger than side B. And I don't need to find H. If I did find H, okay, if I did, it would be 13 times the sine of 68. That's why it's important to draw your triangles this way, because you keep this up and you won't have to worry about it. So 13 times the sine of 68, doesn't matter. It's going to be a smaller number than 13, and it doesn't really affect the outcome of this. There's one triangle because this is the biggest side. Okay, so now we're going to find it. We got to solve it because now I know I can solve it. So I'm going to, well, let me draw it down here so I don't mess up that picture. So now I know, here's C, 68, here's C is 15, B is 13. Now let's label the rest of this triangle. So if this is B, that makes this angle B, which makes this angle A and this side A. So what do you need to find? Okay, what's missing? We need angle A, we need angle B, and we need side A. Okay, remember, always are going to be three things that are missing in a triangle. All right, well this time I can't, the angles are going to be a little bit harder to find because I don't already have two angles, so I can't just add them up and subtract from 180. So now let's look at what I've got. I can't use A, I don't have A at all. Okay, what I do have is C's, and what I'm looking for then would be B, because I can do B's and I can do this. So I'm going to start by finding angle B. Now this is one of those cases where I have to do it in this order because it doesn't matter what's smaller or what's not, this is all I can find. So I'm going to start with the sine of B over B equals the sine of C over C. Okay, that's what I want to start with. Now pay attention to this because we are looking for an angle. That's different on your calculator, so I just want to make sure you understand this. So let's put in our numbers. So the sine of angle B, that's what I'm looking for. I don't have angle B. Over side B is 13. Equals the sine of 68, that's angle C, over side C was 15. Okay, now watch what happens when you cross multiply. Okay, we're going to do 15 times the sine of B equals 13 times the sine of 68. And then what are we going to divide by? Last time, all those other times we were dividing by the sine of the angle, but I don't have B. So now I'm dividing just by 15. Okay, remember the other ones had a sign in the bottom. This does not. All right, so when you do this on your calculator, this is not angle B. This number, it's going to be a decimal, is the sine of B. Okay, be careful with this. So when you put that in your calculator, 13 times 13 times the sine of 68, divide that by 15, we get that decimal, okay, 0.8036 if I round it. Don't round it on, leave this in your calculator. I'm just going to round it to write it down. 0.8036. Okay. All right, making sure that I had that right. Okay, so that's the sine of B. So you're now solving for B. So how do you get rid of sine? Well, when you move it over the equal, remember that's the inverse. Okay, so we're going to do the inverse sine of that number. Now, when you do this, don't round it. So keep that right where it is. And we're going to do second sine, that's the inverse. And then remember, just hit second answer, or just go up and copy and paste that, whatever you want to do. Okay. And you should get 53.47. Okay, 53.47. Now, please make sure you don't round this too much. Now, you can just type in 0.8035593 here, that's fine, or you can copy and paste it, however you want to do it, but don't round that number too much, because if you round it too much, it's going to throw off this, okay? So I just like to keep the whole thing in there when I do it. All right, so that means B is 53.47 degrees. All right, so I got B, 53.47 degrees. All right, now do I have to go through that again for angle A? Okay, hopefully you'll say no, okay, because now I have two angles. So now that I have two angles, I can find angle A by just doing 180 minus these two numbers. So angle A is 180 minus 68 minus 53.47. I always like to put degrees on everything because that, I know I'm looking for angles. So 180 minus 68 minus 53.47 is 58.53 degrees. So there's angle A. Okay, so that's 58. Did I write that right? 58.53. All right, so now I got my three angles, and now all I'm missing is side A. Uh-oh. See, I knew I did something wrong, just didn't know what exactly that was. All right, angle A is 58, angle B is 53. So now all I'm missing is side A. So that now requires me to go back to the law of sines. Remember, you cannot use the Pythagorean theorem, okay? That will not work. So I'm going to set up the sine of A over A equals, now again, I can use either C's or I can use B's because I have both of those. I'm just going to use C because those are easier numbers. So the sine of C over C. So fill in what you have now. The sine of A, which is 58.53, over side A is what we're looking for, equals the sine of angle C, which is 68, over side C, which is 15. All right, now we're going back to the old thing because now I'm just looking for a side. So this one won't be an inverse. You only do the inverse when you're looking for an angle. Okay, don't lose this step when you're looking for an angle. Okay, so we're going to do A times the sine of 68 on this one equals 15 times the sine of 58.53. Okay, divide by the sine of 68. And then just put that all in your calculator like we did on the earlier ones. So 15 times the sine of 58.3. Get that, divide it by the sine of 68. Okay. So 15 times the sine of 58.53. And then divide that by the sine of 68. So we get A to be 13.798. So if we're rounding to the nearest hundredth, that would be 13.80. So there's side A, 13.80. All right, so does it work? Where's your smaller angle? Right here. So this should be the smallest side, which it is. This is the middle angle. That side's the middle. Biggest angle, biggest side. Okay, so again, check that to make sure that at least you didn't mess up and do anything incorrectly. Okay? All right, I'm going to stop here and then we'll finish up on the next video.